Hello everyone, welcome back. So in this video, we are going to understand the LeetCode problem number 3513, number of unique XOR triplets 1. So basically in this problem, we have given an array and we have to find the triplets, right? What is the triplet is there where we have given three indices. Let's suppose I is less than j and j is less than k, right? At each index, you will get three elements, right? So the three elements you have to use the all the elements between them is a XOR you have to apply. That is called the XOR triplets, right? Because you know the XOR operations and triplets means three times, right? So three elements we will use that and we'll apply the XOR. Now we have to return the number of unique XOR triplets from the all possible triplets that we have I, j, k like that, right? We have to find from 1 to n, okay? So basically, what are the number unique XOR triplets, right? So we have to count all those XOR triplets in from 1 to n, and we have to return that, right? So basically we have given nums we have given, and let's suppose for the output is 2. So it is saying that the possible XOR triplets are like this, but only this 1 and 2 is repeating. So we can say we have to take unique as a 1 2 only, right? We can say that. So this is what the question says, okay? Now let's talk about the solution here. The solution is what we have given. If you want to see only solution, this is the solution. But how this works, let's understand. So the very first, we should understand what is XOR operation is here. Okay, what is exclusive XOR or? So exclusive XOR or XOR operation is one of the most important bit manipulation operations in DSA and coding interviews, because you will see multiple times in the lead code problems as well as in the coding interview. Okay, so this is very fundamental to you should understand the XOR. Okay, so once you understand its rule, many problems becomes much easier. So think of XOR as if you find two different bits, right? It will that will come 1. Means different means 1, same means 0. Okay? So two bits are same, results to 0. If two bits are different, means results to 1. This is the simple trick that you should keep in mind for whenever you see the XOR. Means if same means 0, if different means 1. This is the XOR says, right? Formula says. Let's talk about the XOR truth table. Okay, so XOR is saying that we have A and B two number we have, right? And let's suppose A contains some bits like this and B contains some bits like this. So if we check each bits, right, let's call 0 and 0. So both are same, right? Here and here both are same. Means what you will get? You will get 0. Means you are taking the A or B, right? So if this is 0 and this is 1, right? 0 and 1. So what will come here? It will come 1. If we'll take 1 and 0, what will come here is 1. If we'll take 1 1, what it will come, because both are same. So whenever you see the difference, right, then you are getting 1. But whenever you see both are same, right, means we are getting 0 0. Correct? So this is the thing you should understand when we are talking about the XOR, right? For example, let's go with the A is 5 and B is 3, right? So let's take the very first step where we want to convert to binary, right? Means the 5 will become 101 and 3 will become 011, right? Like we know that, right? Because the binary is 0 and 1, right? It consists of. We'll take the step 2 and we'll compare each bit. The very first is 101 and the XOR is, if you'll take this one, right, if you'll apply this one, right, because these two things is there, right? So 1 is 0 because both are same bit. This is same bit, this is different bit, right? So if different bit is there, we'll use 1. This is also different bit, so we'll use 1. Because this 111 is same bit, so we'll use 0. Otherwise these two are different, so we'll use 1 so it become 1. And we know that 110 is nothing but the 6, right? So we convert back to the decimal from the binary to decimal, so we'll got the decimal value 6. So in the short, we can say that 5 XOR 3 is nothing but 6. So how will you get it? You have to convert into binary, then you have to compare to the each bit, and then we'll apply the XOR formula, and then you will see that, okay, let's get back to the decimal, and you will see the answer is there, right? So I hope you understand the XOR. Let's coming back to the our original problem. The problem was the number of unique XOR triplets, right? So the step one was a step one. We can say that what is a triplet? Okay. So a triplet is choosing three positions in the array. The condition is the I should be less than equal to j and j should be less than equal to k. It is not only less, but it is also equal to, right, in each of these, right, condition. I less than j less than k, but I also equal to j and j is also equal to k. That is a possibility, right? That is called here triplets, right? So we should understand exactly what the condition we have given, right? Further, it is saying the notice what you should understand is indices can be equal, right? This is what we are talking about, and you are allowed to use the same number multiple times because you see this value. Okay, let's go to the next. The very first, for example, if we have nums 1 2, the indices we will choose here is either 0 or 1. So let's take, we have two indices 0 and 1. What are the possible triplets are? So if I'll take the 0, we'll say all zeros are 0 0 1, 0 0, right? Then we can take 0 0 1, then we take 0 1 1, then we take 1 1 1. So like that we have. So if you see here, right, 1 0 0, because 1 is greater than 0 here, right? So that is not possible. So we should think what are the possible triplets are. Understand? Because the condition doesn't match for 1 0 0. Okay. Now compute the XOR for every triplets that we have given for 1 2, right? So the very first triplet we will choose is 0 0 0, right? And we will apply, so all are same, right? One XOR 1 and this, right? So when we see one like the same one, right, we will get the 0, right? And here 1 XOR 1 is 0 and 0 1 is 1, right? So we'll say 1. Then we'll go for the 0 0 1, we'll say 1 1, and this, right, we know that we see that value. Like that we will calculate all these triplets, right? And we have the triplets for the 1 2 3 and 4, all having the result here for each one, right? So we can say that. Let's go back to the collecting all the answers, right? We obtained 1 2 1 2, right? Like that we have found. This is got with for triplet 1, triplet 2, triplet 3, triplet 4, right? You can pause that and you can see that. So the unique values we got is 1 2, right? And so the answer is 2. Understand? Let's understand example 2 where we have 3 1 2. It's very important to understand. So the possible triplets are what? These are the possible triplets. Okay. So if we want to compute XOR for each one, right, we'll apply this formula, right? So some examples, let's suppose we'll get 3 3 3 3 3 3, this, like we can get 3 1 0 1 2, like that we can compute this value. So finally, you suppose that we have a distinct XOR values that comes from 0 1 2 3, means these are the unique values we are seeing each time, right? So if we are getting these values, right, some maybe duplicates are there, but let's suppose mostly we got what, 0 1 2 3, right? So these are the distinct XOR values we got, right? So the final answer is 4. So like that we have to think and we have to understand the problem, guys. Okay, understanding the example is very important. Now, why can indices repeat? Because the problem explicitly says that I should be less than j and j should be less than k, but it should also be equal, right? So instead of saying I is less than j, j is less than k, right, that means 2 2 2 2 is completely valid, right? This is the trick that many people, guys, miss, right? Okay. Now you should also understand that we have talked about XOR properties. So you should always keep in mind that if the same is there, same bits are there, means it will be 0. If different bits is there, it will become different, right? If it is different, same bit is there, then it will be same, right? Like that we should also think, guys. Okay. What is the hidden observation? The array is always a permutation of 1 to n, right? It means what? Either we can say 1 2 3 4 or 2 1 4 3. The order doesn't matter because every number from 1 to n appear exactly once. Okay, so this is also a very good observation that you should keep in mind. Now it is very important to understand this step. So for because we know that order doesn't matter, right? So for n is greater than equal to 3, every XOR value from 0 up to 2 to the power k minus 1, right, where 2 to the power k is the first power of 2 greater than n can be formed, right? So therefore, instead of checking every triplets, the answer is simply what? If n is equal to 1, it means it will give you 1. If n is equal to 2, it will give you 2, right? So otherwise, the smallest power of 2 greater than n, correct? So this is exactly what the base case is computing. So very first you will make the condition if n is equal to 1, we will say 1, we will return 1. If n equal to 2, we will return 2. Otherwise, we have to find the smallest power of 2 greater than n, correct? So let's suppose, so we found that if n equal to 1 and n equal to 2, let's suppose n equal to 3, means what? The next power of 2. What is the next power of 2? That is 4. We will check for the 5. What is the next power of 2? Is 8. Like that, we'll keep checking. If n equal to 8, what is the next power of next to 2? From 8, it is 16. So this is why the solution runs in O of log n times, right? And the space is O of 1, right? Because we are checking with all the triplets, guys. Okay, so we should also think about this logic. Okay, now comes to the problem, right? Solution. So we have seen that this problem, guys, right? It's a medium level question and it's very understanding about the permutations, right? So you have seen why we have choose the conditions. So as we understand, if the permutation order doesn't matters for the array, right? So we just say that if n is less than equal to 2, right, we will return n. Otherwise, we will find the next power of 2, right? So we'll take the answer is 1 and we'll check, okay, while answer is less than equal to n, right? So we'll take answer and the shift will take double shift will take is equal to 1, right? And we'll keep checking the next value and we'll return the answer. Okay, so this is what we have in this video, guys. If you still have any doubt, let me know in the comment section you understood the problem or not. And if you have got any doubt, let me know in the comment section. Thank you so much for watching this video and I'll see you in the next one. So till that, thank you so much for viewing and please support Express Funda in case you are new at Express Funda. Please like and subscribe this channel. Thank you.